Assalamualaikum dan salam sejahtera. Well, this time I would like to show to you how I'm going to use the hole wizard in order to create any types of holes on a flat surface. So let's say I'm going to pick top plane as my sketch plane, and then I'm going to pick a center rectangle. I'm going to start my rectangle at this origin, right? And then I'm going to indicate my dimension. This one is 100, while over here the length or the distance is, let's say I'm going to make it 200 mm. Okay, and then I'm going to extrude this sketch with the height or thickness. Let's say I'm going to make it 30 mm. All right, so let's say I'm going to have few holes over here. Okay, uh, normally, if you were to create a hole, true hole or a blind hole, you can just simply go to sketch and you can pick the circle. However, this time I would like to show to you how we can use this hole wizard, okay, in order to create a few types of holes. Okay, in order to choose or to apply this hole wizard on your part, you no need to pick the plane first. Or let's say I'm going to create a few holes on this surface. So it is not necessary, or I no need, okay, I no need to pick this surface as my sketch plane. I straight away need to choose hole wizard. If you expand this, there are few more holes such as advanced hole as well as straight, but I want you to pick hole wizard. Okay, we focus on the hole wizard. Go to hole wizard. And this particular of whole specification dialog box will appear in our manager design tree here. And as you can see over here, we do have two types of tab. One is type, another one is position. The type is a tab whereby we can choose a type of holes that we're going to apply on our part, whereas the position tabs is where we're going to locate our holes later on. All right, so first of all we need to pick type first. All right, and there are a few types of hole. We do have countable, we do have countersink, or sometimes in industry we call it as countersunk. We do have hole. This is a normal hole. This is a straight tab. Okay, it means that hole with threaded. Okay, lubang dengan berbenang, hole with threaded. This one is another tab, okay, and you can glance through all this. But normally, in SolidWorks in design, we're going to use the countable, uh, countersink hole, the normal hole, as you can see over here, which is straight tab or holes with threaded. Okay, all right. So this is slot, all right. However, we're going to focus only on countable, countersunk holes, as well as the holes with threaded holes, okay, which is also known as straight tab. Okay, let's say I'm going to pick the normal hole first. Okay, pick this one first. Okay, you just pick this one. All right. Reset. I'm going to reset first. Okay. Uh, I'm going to pick this hole, okay, first. And as you can see over here, there is standard over here. So we're going to pick the ENSI. They do have a lot of British, Japanese, or whatever. So we're going to choose ENSI metric, right? And type, we're going to choose the drill size. Okay, we do have helical, screws, clearance, but we're going to use drill size because in order to create holes, we need to use drills, right? So in this particular case, we need to choose drill sizes. Okay, let's say I'm going to make the diameter of the normal hole, okay, true hole. Let's say I'm going to make it 10 mm. The diameter of the whole time, so I'm going to scroll down and I'm going to look for 10 mm. Okay, there you are. So diameter 10 mm, right? And then This is blind, but as I mentioned to you just now, that I'm going to make it true all. Okay, tembus, lubang tembus, true hole. All right, so that's why I need to pick true all. All right, and then once after confirm all of these, we need to look position, or we need to locate the hole that we're going to apply. So we need to choose this position step, and then we just simply pick this surface. Okay, just simply this surface, right? And then we just simply look at anywhere. Let's I'm going to make it 1, 2, 3, 4. Okay, so I just simply need to pick 1, 2, 3, and 4. There you are. All right, 10 diameter holes with true all. Okay, once after you already locate, you just simply randomly locate on the surface, and then once after confirm that all these 4 places that we're going to locate with our hole, then what you need to do is that we need to apply the dimensions. So in this particular case, I'm just to go to smart dimensions, and then I'm going to pick the center point of this hole to here. This I'm going to make it 30. From here to here is, let's say I'm going to make it 20. From here to here is the same, 30. And from here to here also same, 20. Same to go with both of these with these 2 holes. Okay, if it is much more easier if you are not really familiar in order to indicate dimension in isometric view, you can just simply go to here and normal 2. There you are. Okay, right? So now I'm going to look at the dimension as well, but this time I'm going to show to you how are we going to apply constraint. So how are we going to apply constraint? So I'm going to right click and select. So I'm I'm going to make sure that this hole should be aligned with this hole. Okay, vertically aligned with this hole. So in this particular case, I need to pick this one first. Don't pick this one, this center point first. Pick this center point of this hole first. Why? Because we would like to make this center point as our reference point. Okay, that's why we need to pick this one first. So pick this one first, and then press Control button. Do not release that Control button yet, and then go and pick this center point. Once after your this dialog box appear, then you can release your Control button. Okay. Now, since I did mention to you just now that I'm going to make sure that this hole vertically align with the bottom holes, this one. So I just need to constrain it, okay, existing relation, and then I need to constrain it with vertical, add relations with vertical. There you are. Okay, same to go with this one, but you need to do it one by one. Click OK first, and then again, you need to pick this particular off point, and then Control button, pick this point. Now you can release your Control button, and again I'm going to add a relation with vertical. There you are. Okay, so actually guys, you can indicate the dimension also if you want to. Just pick the dimensions, pick here center hole here, then go pick this edge, and then you can indicate it as 20 mm like this. But this is another way in order to align all these particular of holes. Okay, since over here I do not have any reference in order to add a relation to constrain it, so I'm going to add just one dimension over here, which is 30. Okay, once confirmed. And now I want to show you to use the constraint or add a relation with horizontal constraint. So once after confirm, again, since I would like to make sure that this hole need to be aligned horizontally with this hole, so I need to pick this center point first, and then press Control button. Do not release that Control button yet, and then pick this center point. So once after this dialog box appear, you can just release your control button, and then of course definitely if you would like to align here, we need to add relations with horizontal constraint. So pick this horizontal data. So now we already have all these four holes at its uh, positions that we want. Okay, so once after confirm, you just need to click OK. All right. So this is how you can apply your holes on a flat surface on a certain part. Uh, I'm going to show to you another one more example, which is countable hole. So you can go to hole wizard, and this time, as what I did mention just now, that I'm going to apply countable. So I need to pick countable hole. What does it mean countable hole? What does it mean by countersunk hole? You need to go back and do research. You do your homework and find out what does all this means. All right. Again, I'm going to maintain with E in asymmetry, and types I'm going to maintain with hexagonal bolt. This is type of bolts that we're going to apply later on to match with these countable holes. So I'm going to fix with this one, right? And then the size, I'm going to make it let's say I'm going to make it M14, right? And it should be true all. If we're talking about countable hole, it should be true all. Okay, so once after confirm, I need to position this hole. So I just pick here, positions, and then once after you pick the position tab, you have to make sure that you choose this surface, since we're going to locate our countable hole on this particular surface. So I'm going to again I'm going to locate the one here, 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 and here. So we just simply need to locate first. Okay, once after confirm, again, if you not really familiar with the dimensions in isometric view, so you just need to go to here and go to normal true. Okay, normal 2. And then you can just straight away go to smart dimension, and then we go to here to here, which is going to be 25, right? And then the dimension from here to here, I'm going to make it, let's see, 65, right? Now, I can just pick this one. I'm going to constrain here, press Control button with this one horizontally, right? And then I'm going to smart dimensions from here to here is 25, right? Again, I'm going to align this one with this one. I'm going to constrain with vertical. Same to go with this one. I'm going to pick this one first, the center point of this countable hole. Press Control button, pick this one, then vertical. And then I'm going to indicate my dimensions. From here to here is 65. You can locate straight away 65 also, or you can add relation with horizontal. Okay, but I would like to show to you how to play around with the add relations or constraints. So pick this one first, control button, pick this one, and should be horizontal. There you are. So you already locate all those four countable holes at its positions. Okay, then you just click OK. There you are. Okay, so that's how you can play around with your command, which is hole wizards. All right. Okay. That is for hole through. Let's say if you need to have a blind hole. Blind hole, it means that you do have you're going to create a hole with a certain depth. Okay, dengan kedalaman tertentu. So again, we need to go to extrude cut, and then just pick this surface. Sorry, extrude cut. Hole wizard. Okay, hole wizard. Sorry. hole wizard, and then we pick this surface. Sorry, before we position, we need to choose type first. Let's say this time I'm going to make straight tab. Okay, straight tab, ENSI, and I'm going to make sure it's tapped hole. Okay, tapped hole means the hole with thread, and then I'm going to make it, let's say, okay, I think I'm 14 times 2 lah. Okay, this is actually the pitch. Okay, the pitch of the screw 2.0, 1.5. Okay, if you want to know further about this, please do research about this. All right, and I want to make it blind, means with a certain depth, whereby the distance from here, the height of this part is 30, so it should be less than this height. So I'm going to make it 20 mm, right? Okay. Same to go with this one, which is I'm going to make it 20 mm as well. All right. And then I'm going to position this, go to position tab, and I just simply pick this surface. Okay, let's say I'm going to pick here one and here one. Okay, so just simply pick 1 and 2, right? Once after confirm, I just need to pick my normal 2, and then I'm going to indicate my dimensions from here to here is 25, let's say. Okay, same to go with this one, 25. You can add relation if you want to, but in this case, I just simply, uh, you know, locate this hole from this center point to this edge with dimensions. You can do the relation between both of this one, right? So now I'm going to align these together with this as origin. So I'm going to pick this origin first, and then Control button and pick this one, and then I'm going to make sure it's horizontal. Click OK. Again, I'm going to pick this one, this one. I'm going to make it horizontal. Right? Okay, there you are. So once after confirm, you just need to click OK. So how are we going? As you can see over here, the difference between hole, threaded hole, hole with thread, and also hole without thread, there's an additional line, okay, circular line like this. Okay, so if we see that, oh, there's a additional circle line on top of this hole, it means that this is a threaded hole. Whereas for this one, okay, it is a normal hole without any thread. All right. So if we pick the side view, let's make it right side view, and if we go to hidden lines visible, as you can see over here, this is how it looks like. All right, and this is true hole. Okay, as you can see over here, you cuma ada one straight line here, one straight line here. Since this is a true hole without thread, and this is a hole with thread, if hole with thread, they do have two lines like this. And since it is blind with a certain depth, which is 20 mm, so the depth from here to here is 20 mm, not from here to here. Okay, not the depth of this threaded hole, not from here to here is 20. No, the depth is from here to here is 20. Right, guys? So that is how you can apply your hole wizards in order to create a few types, okay, few types of holes on a flat surface on a certain part, like this one, okay, that I've showed to you just now. Okay, guys. So hopefully you can try out. Okay, and thank you for watching, and I will see you in our next video. Thank you very much.